Hello, my name is Jamie Rodriguez, and together with my partner Lady Rodriguez Fordosa, we are going to explain about three topics that we see in a physics subject. So, the first, I'm gonna explain you about the topics in the first term, that is about the distance, displacement, the velocity, and speed. So to explain you, I'm going to do with a toys car, and I'm gonna simulate that the car is a real and try to do the distance and displacement real. So use your imagination, please. The first project the car did is with a distance of 23 centimeters with a time of 1.36 seconds. The second is to the right with a distance of 28 centimeters with a time of 1.75 seconds. The third is again to the front with a distance of 29 centimeters with a time of 2 seconds. The third is to the right again with a distance of 26 centimeters and the time of 2 seconds. And the last to the front is with a distance of 31 centimeters with a time 2.7 seconds. So here we have the car journey or the trajectory that the car did. In this part we have the directions that the car did with the distance and the time, each time and each distance. So in this case we are going to do the exercise to find distance, velocity, speed and displacement. So first, to find the distance we have to addition each distance in each trajectory that the car did. So in this case is 23 plus 28 plus 29 plus 26 plus 31. And the answer of the addition of all is 137 centimeters. After of that, we need to search the distance in x and y. Why? Because we have to find the displacement. And displacement that you can see the trajectory is deformed like a triangle. Yeah, in this case it's a right triangle and it's necessary to apply Pythagoras. So in this case we have these dates. Why? Because the direction are positive or the right and not the left in two cases. So in each, I don't know, say catetos, you put in x and y and operate like a formula. So after of that, like you can see, this is the formula and we apply the numbers of the distance here. So you can have the answer, and in this case the answer is the displacement. So if you remember, the formula of the distance and velocity is distance over total time, that is speed, and the velocity is displacement over total time. Okay, like you can see, we have the distance and displacement right now, but the total time would happen. What happened? So in this case, you need to addition of time, all of time, to have the final time to apply with two formulas. So the distance, like I say, is 137 centimeters over total time. In this case, 11.14 seconds. And you divide this and obtain that. Now the velocity is displacement here, and we have the Pythagoras over total time. The answer of that is 19.2 centimeters over 11.14 seconds, and the answer is 8.188 centimeters over second. In this case I haven't to find speed and velocity in each point because it's so long, so I haven't time to explain that. So I had this in general. Okay, so this is the exercise and no more. Electromagnetism. It's the flow of charges that is called electric current, in which a magnetic phenomenon is generated around a file. The first example, you need to roll a plastic bag on someone's hair for a short time. Yes. Then you are going to leave the bag and you are going to notice the magnetism that is generated in the hair. Yes. So here the flow of charges come to the movement, this movement of the bag with the hair, which is create magnetism on the hair, as you can see. For this second example, we need to rub a comb on someone's hair, as I do, for a short time. Then we are going to put on the piece of paper and we're going to notice something. So after a short time, so we're going to put the comb on the piece of paper and we're going to notice that they interact, and it's a little bit the result of the example before. So in this case, the movement that we did with the comb and the hair create an electromagnetic and electric current that acted in the piece of paper and generate a magnetism. So for the last example, we're going to use these batteries, and I'm going to try to explain you the type of electric charges that is positive and negative, and they interact in this way. So as you can see, negative and negative sign, they repel. Yes, and if we do the same with positive and positive sign, they repel as well. But for example, if we put negative and positive, they are going to attract. So the first law of Newton tells us that an object will not change its motion unless acted on by an unbalanced force. So for example, the car is still, yes, but if I do the car move, yes, because the force comes to my hand and change the movement of the car. So as we can see, the car was moving and my shoes stopped because it's the force that stopped the acceleration and movement of the car. Imagine that you are look since here, yes? So you look that the car pass, yes? And you look that the pencil and the car move at the same time. But if you analyze, the pencil didn't move, just it was that the car made a force, and this force made that the pencil move. So imagine that we are getting into the car and the car start move. So since this place, we notice that just the car move, the pencil was still, and we were still as well. So with this idea, the law tried to explain us that it depends of the place that you look the object, you are going to understand its motion, yes? Because as I mentioned before, getting the car, the movement is different, and outside the car, the movement is different. So here we have the formula that you can use for apply the knowledge that you got before. So the formula is mass 1 dividing mass 2, and this is equal to acceleration 2 dividing acceleration 1. So please remember that is crossed 1 1 2 2.